Okay, my name is Alexander Podkhalyuzin. So yes, that's right. That I came from St. Petersburg, where Kotlin Island is actually exists, and we called, similar to Java, the language to our island. So I'm Kotlin IDE team lead, and if you have any questions around IDE, I can answer also after the talk and later during the beer time. And today I'm going to do some inspirational talk, which is good for the last talk. I mean that this is kind of technology which is not yet production ready. Kotlin JS itself is production ready, but multiplatformity is experimental. We are doing lots of progress in that, but and we want to inspire people to try it and to understand how to use it and to give us feedback, because together we can actually create incredible stuff, and in future, like doing Kotlin on all the different backends. So what is different backends? Kotlin right now is not only JVM, which is most known like Android backend. It also has two different backends for JS and native. Native is for LLVM runtime. Do you know Kotlin JS, that Kotlin actually is possible to compile to JS? Anybody of you? Nobody? So it's a great time to learn it actually, and I want to do some simple introduction to that and describe you something about Kotlin JS. As usual, at some point, somebody from Kotlin team decided to experiment and try to compile Kotlin to something like JavaScript. And later, few people started and did a completely different backend. That's how this project happened, and now it's in production state, and much more people works on that. So let's see the raw example. Let's do the presentation mode. Sorry. Let's create new project, which is Kotlin JS. We do it for Node.js, something here. So what is Kotlin JS? It's just a plain compiler, and also it has to interact with JavaScript runtime. So we need to be able to call JavaScript things, and vice versa. We need to be able to call compile code from JavaScript. And all of it is done in actual environment. So here we have a plain project. So, sorry. Okay, so here is our plain project, and let's create something in Kotlin. Do you use Kotlin production, any of you? So only one people, few of you. Okay, so let me ask you some tricky question. Let's implement simple factorial function. And do you know the way how to implement in one line? Let's do it like in integers. So anybody have ideas? So usually factorial requires some cycle, but if we use functional technique, so we can do it in one line, like this one. And now we just need to put this code. So that's it. And do you understand this code? Okay, so it's actually, we took this range from 1 to n, and we did a fold function, which took the initial value and then adds one by one from the range and multiplies them, so accumulates the things. And as a result, we get the production of the all these numbers from 1 to n. So let's put the main function and check what's going on here. Factorial function, is it right or not? So let's run it. We can run it. And here we are running JavaScript code, actually, in Node.js environment. We can take a look for actual JS code. So it's here. We can see the compiled code here. Funny thing is that due to the Kotlin magic, which inlines everything, here we see actual accumulator and cycle. That's how usually we would write factorial function. And we can see here actual function, how it named. So if we want to call from JavaScript this function, we need to invoke factorial, ZA, and so on. This looks wrong, but there are some tricky things. We need to export this name to the JavaScript, and we can just call it factorial. The main reason for this is when we have overloaded function, which is not supported by JavaScript, translator to JS just don't know how to name it inside of JavaScript runtime. So if we recompile it, then we can take a look here, and we can see that actual name is now factorial, and we can invoke from JavaScript this factorial function. What else we can do is to run tests. It's still the same Kotlin, and we create factorial test here, like factorial test, and let's test it. Let's test 5, as we tried already. And so we expect, as we saw, we expect 120. But let's do some mistake and put factorial of 6. In Kotlin JS, it still has some lacks of tooling support. So here it's the feature which is coming soon. I mean, running tests right from IntelliJ IDEA. But for now, we need to use Gradle task to run it. So we can run it and see that actual error of this test is here. We can take a look for the actual failure, and it's exactly what I intended to do. This is mistake that actually is 720 and 120 is. So yes, we can simply fix it and rerun it, and everything is fine right now. So that's it. That's simple introduction into Kotlin JS. You actually, if you want to dive more into Kotlin JS, it's pretty straightforward. You can use NPM libraries right from the Gradle. So you can add them to dependent and call JavaScript functions right from Kotlin. So that's everything is possible here. Let's turn to slides. So the most interesting part of my talk is actually Kotlin multi-platform technology. And if we can compile code to JVM as well as to JS, so it looks like we can do the same code and just compile it twice, and that's it. That's our multi-platformity. But actually, this is wrong. I mean that in this case, we could compile pretty simple algorithms, which based only on Kotlin standard library. Because if we start using, I mean that Kotlin JS compiler is not the same like on JVM. We can't call Java IO functions, so we don't have IO, we don't have Java math, and so on. So we don't all the Java libraries. And the same for JavaScript. On JVM, we don't have all the JavaScript libraries. So if we have like single folder with the same code, we can't use libraries from Java or JavaScript. So in this case, we need to support something which we called Kotlin Multiplatform. And what we actually need to support, we need to implement lots of tooling around that. First important thing is language support, which requires something we call expect actual, which means that we can define in your code expect declaration, and in real platforms define actual declarations, which is calls, for example, native libraries for example, system time. We can call this differently on JVM or on JavaScript. So another thing, we need some build tool support, because dependency management can become kind of hell. Imagine that we just now have, for example, 2 backends and different set of libraries. So if we depend on another multi-platform project, then JavaScript part should depend on JavaScript part, JVM on JVM part, and common part also should depend on the common part. And this is already 3 dependencies. And if we use more platforms, then we can get combinatorial complexity of dependencies between different platform parts. And this requires build tool support to actually help us. And important also thing is IDE support, because in the IDE we should support all this new language stuff and synchronize Gradle build tool into IntelliJ part and so on. And what is the most important from tooling perspective is that we need to be highly interoperable with all targeting ecosystems. So if we do, for example, iOS platform, we should be very, very interconnected with Swift and call all the iOS APIs, and same for JavaScript and JVM. So what is actual target in multi-platform? It's much more than just backend. So originally we thought that we have 3 backends and that's it. We have 3 targets. But even for iOS, we have 3 targets. It's ARM32, old iPhones, ARM64, and simulator thing, which is x64 platform. And this is completely different sets of libraries, and we need to recompile to all of these targets separately. For JVM, we also have different versions, so it's JDK 9, 13, and Android, so it's also different targets. And we can even think deeper, I mean that we can consider like different libraries is also different targets. So for example, for JVM, we have 2 most popular test frameworks like JUnit and TestNG. So Kotlin Test, we can like implement like multi-platform library, and for these different targets, like different set of dependencies. And that's it. So what is common? I used this term before, so like common code, and you can imagine like this is the pure Kotlin ecosystem. So common can depend only on common, which is at final dependency will be Kotlin standard library at all. But in reality, you have common code, for example, just for iOS platform, which already have 3 targets. So we actually need to have common library for all iOS APIs, and this common part will depend on this common library, which is not from Kotlin ecosystem. So it's more complicated, and we build much more complicated hierarchies in this. But originally, we definitely thought that this is like pure Kotlin ecosystem. What is expect actual? I already told, but it's much simpler to understand if we consider common part as like abstract class. So for example, we can do lots of things except, for example, calculating which current time milliseconds right now. And this is abstract function. And on the real platforms, real targets, we have implementations for it and calls to actual native APIs. So in this case, we can simply understand that these all hierarchies of multiplatformity is just like object-oriented programming with abstract class and implementations. So as a build system, we chose Gradle, which is I would say obvious choice for us because Kotlin is most popular for Android environment, and Gradle is default build system there. I would say the only build system. So we need to support any build system, and we chose most popular for us. So it's definitely Gradle. But as I already told, we needed it anyway to support this complexity of dependency management. So originally, this original topic of this talk was about how to share code with JavaScript. I actually thought about showing you live demo about sharing, but I decided to show demo around full stack application, so which is probably even more exciting, even more experimental, but more interesting from perspective. What if we want to, for example, if we have JVM server and parts of it is possible to share with JavaScript developers. It can be, for example, some validation code, which we definitely need, for example, to do on both client and server. When we put some forms, we still need to recheck on the server after the REST API call. We would like to do it once, and different people decide to do different approaches, how to share it. So, for example, Node.js is one of the answers. So when we go to the pure JavaScript ecosystem, and in this case, we can reuse JavaScript code from front end in the server. But this is the step from other side. I mean that lots of servers are still Java, and it's very popular choice. So sometimes we want to share it to the front end, and it's possible now. So we need to extract some independent part, which is common, which we want to share, and then extraction can be tricky, especially if we had lots of dependencies to the Java ecosystem. So we need to replace lots of parts to the Kotlin multi-platform libraries as much as possible. So right now we have Kotlin HTML libraries and HTTP libraries, so we can do HTTP calls on all the platforms. We have a coroutine libraries, which gives us multi-threaded possibilities in the same way on the old backends. And we also, for example, have a serialization, which is also multi-platform. So we can actually serialize code on the client, send to the server, and deserialize in the same way with the same library, which is multi-platform. So if we change these dependencies or just extract very simple, straightforward code which depends, for example, only on standard library, then we can move it into a multi-platform model. And that's it. If we have multi-platform module, we can generate and deploy it as JavaScript library and then give it to JavaScript developers. And only thing is that we probably need to name functions as I showed you with the annotations GS name. I wanted to continue with full stack application, which is Kotlin Conf application. It's going to be our showcase for the Kotlin Conf conference, which is going to be quite soon. It's still under construction. You can see the link here. If you watch video later, so probably it's already not in the branch, and probably it's part of the master. But right now, it's a branch which is under development. And Kotlin JS is not yet there, but we are going to implement Android web application fully in Kotlin JS. So it would be actually possible to do in plain JS, but for us, of course, it's more interesting to implement, to do everything in Kotlin. So let's take a look for it. So let's close project and open our Kotlin Conf project. It's slow as for some reason. Okay. So that's it. Let's take a look for the structure of this project. Here is our main build Gradle.ks file, which is not multi-platform, but it collects all the zoo of different modules we have. Actual multi-platform code is here, which is common. And here is our Gradle script, Gradle DSL, which we use. So we define different targets. We define how to compile it for iOS. And as there is no yet JavaScript, there is only JVM and iOS. JVM is used for both server and Android, and iOS part used only for iOS. So here's the Android part, and let's, for example, run this Android app just to see that it works. So yes, this is probably it's weird to say you don't miss it because it's fully sold out right now, so it's pretty simple to miss it. Something happened. But yes, if you have ticket, so don't miss it anyway. So let's continue. What is in common? In common, the most interesting part is to understand what is our expect functions, because it describes differences between different platforms. Here, this is different. What is different is generate user ID function and dispatcher function. What is dispatcher function? We use it to dispatch coroutine threads and how to run it in multi-threaded environment. And on iOS, it dispatches to, it should work in different way. Problem of this code actually is that this should be part of library. I mean, that should be covered by coroutines library, and this dispatcher should be inside of iOS support. And it will be. I mean, that this is showcase, and we are experimenting with this. So we can put hacks here. So I would say this is definitely hack, because for the user, it shouldn't be required. And in future, it will be definitely. But for now, yeah, we can even, even if you are not able to do something, you can just implement in platform separately and still work and so on. That's completely different from our usual multi-platform technology, which we had and have and still have. Because if you miss something, you can implement and do it natively in the platform. Moreover, we don't require to implement UI in Kotlin, for example, because as you can see here in iOS part, all the iOS part written in Swift here. So this is only UI part, and all the logic is inside of common code. So Another interesting thing is about JS web application, which is going to be implemented. The only thing we need to implement right now is the UI part. So that simplifies things a lot. So we can recompile this common thing into JS, and then on top of that, write the UI part. Okay. Another thing which was different is how we generate user ID, but this is different because of just different native functions, library functions, which we call. So for iOS, it's like the UI device, and for Android, we do it differently. Here we can take a look how it looks. It's Kotlin native backend, which were not described here. I told we have it, but again, this is completely new backend with own runtime. And if you want to call native functions, you are able to do that. You just need to generate Kotlin APIs on top of native library, which is done by Kotlin, and then you can call it like Kotlin code. So here you can see some UI object with current device value. So what else is important here? So if we have, for example, API, what we definitely have in common is actually our model. So, for example, it's UI state, which is also part of the model. It's shared between all the clients and server. We also have, this model of things we can share between server and clients. So this is all the serializables thing, and we can send it and use it like data classes and simply use it in client and simply use it in server. So what is an API? It's actually our suspend calls, which calls to the REST HTTP things. So it uses a dispatcher, and on JS it dispatches in single-threaded thing. On iOS, it dispatches differently. On JVM, it dispatches by own event threads. And that's it. So we just defined the single function. And on all the platforms, we can just call it and get the asynchronous call to the server. And what is interesting here, we still have a duplicate here. I mean that we have an API call to the favorites. And for example, on server, we implemented it also like API. So we defined it, sorry for red code. We defined it some API. And actually, what is, for example, interesting that we can extract this string, which is the same on both. For example, favorites is interesting word, which is correct spelling with two different ways. I mean, British and American. So it's very simple to do a mistake in this particular thing. So it's a great idea to extract it, and we can actually do it in common code. So if we have API, we can have these favorites. We can put like favorites string, for example, and we can define it here. So we can put it here, and in the backend, actually we can just reuse this favorite string. So it's completely the same and can be reused on both on client and server, and simplifies and reduces mistakes in spelling. In reality, people usually generate code for the client from the server thing. And here we have a duplication because we don't generate code. It's still possible to generate here in Kotlin. But I think that in future we will do some smarter way without generation under the hood inside of compiler. So that's it. and I can answer any questions around multi-platform, Kotlin JS, or Kotlin IDE.
Thank you, Alex, for the session. Here we are picking into things that are still quite in the making. So it's an exciting opportunity for us to get in touch for such situations. If any questions, I don't see any in Slido, but if you have any questions, you can also ask raising your hand, not head. Yeah. Okay, none here. One.
So question is that I said Kotlin JS is still experimental. Actually not. In experimental state is Kotlin multi-platform. You still can use it for production. I mean, try to use it. But I would inspire just to try, like, for experimenting. So that's the most interesting part for us, because we can get feedback from you. But Kotlin JS is definitely in production state, so you can use it. It's released. Moreover, coroutines also released for all these platforms, so it's also in production state. And all the libraries I described is in the same state as well.
What about the iOS part of the multi-platform? Do you plan to be able to completely build iOS applications from IntelliJ?
iOS part is actually always requires Xcode, so it's not possible to build from the...
That's the question. I was trying to circumvent Xcode a little bit, but apparently I cannot still.
And as I mentioned, we not trying to implement all the iOS applications in Kotlin only. So the idea is just to share some framework to the iOS developers, and they can build on top of that. And speaking about experimentality, what I told about multi-platform, it's experimental as a tooling. I mean, if you compile it to the JavaScript, the actual runtime is still in production state. I mean, from tooling perspective, you will get some tricky problems, and that's where we want to get some feedback and go faster and faster.
Any other questions for Alex? No more questions. Then the other questions go when we're drinking beers together. This was the last session of the day. Alex, thank you for having us, for doing it for us.